Hey everybody, remember last lesson, 2.01, we talked about the idea of the parent function of a parabola, and that parent function was y equals x squared. And then we talked about the negative x squared and the fact that the a value takes that parabola and reflects it, or it flips it so that it opens down instead of opens up. We also talked about the slope pattern of a parent parabola. Well, this lesson is going to be expanding on that idea of parabolas. We're going to be talking about how we take a parabola and move it around a graph. So instead of the parabola just being on a y-axis or on the origin where the vertex is on the origin, we're going to move that vertex around. Now, everything else still stays the same. The slope pattern is going to stay the same, which makes it easy to graph, but we want to be able to move it around. So with that said, our objective is to be able to describe how a parabola is shifted or translated by observing its equation. Okay, so in other words, I'm going to give you an equation for a parabola. And remember, all parabolas have the highest power of x squared in there somewhere, highest power of squares somewhere in there. We are going to be looking at specific ones, and we will be able to observe how the parabola was shifted or translated around the graph based on those numbers. So let's go ahead and take a look at exploring this idea a little bit. So remember, anytime we have an exploring problem, we're going to go ahead and put that on the left-hand side of our notebook. And so again, in your notebooks, make sure you got your name, your title, your essential question down on the right-hand side. And then on the left-hand side, we're going to be doing this exploring idea here. So in A, it says that we need to create a table and plot points for the following function. So we have y equals x squared plus 2. Now from yesterday, you should be familiar with being able to graph this line. We can see that we have a y-intercept of 2, and that in this case happens to be our vertex. But we're going to go ahead and create a table nonetheless to make sure that we know what we're doing, okay? So when I create this table, it's always a good idea to pick values that are maybe to the left and to the right of the origin just to see what's happening here, okay? So I'm going to go ahead and pick -2, -1, 0, 1, and 2. That's going to help us see things, at least what's happening in the center of the graph, if you would. So when I go ahead and plug in -2, I'll go ahead and do that work down below. It's going to say y equals -2 squared plus 2. And then simplifying that, -2 squared is 4 plus 2. And then we end up with, oops, thinking ahead of myself, -4 squared is 4, and then plus 2, which is 6. And so in our table, when x equals -2, y equals 6. We'll go ahead and do the same thing for the -1. So -1 squared plus 2, which is y equals 1 plus 2, or 3. So we have that one. And then for 0, we can just do that one in our head. 0 squared is 0, plus 2 is 2. And then 1 squared is 1, plus 2 is 3. And 2 squared is 4, plus 2 is 6. Again, you should be able to graph this on your own without that table based on the lesson that we talked about yesterday, or the last lesson we had. But it's a good idea to see the table so you can see what to do in the next one. So the first coordinate is -2, 6, so back 2 and up 2, 4, 6. Next one is back 1, up 3. The next one is just up 2. The next one is right 1, up 3, and then right 2 and up 6. And then we can get our idea of what this parabola is going to look like by connecting those dots. But I wanted to emphasize this so that we can remember what we talked about. We start up 2 because of that plus 2 there, and then we follow our slope pattern. Remember, our slope pattern is 1, 4, 9, which means from the vertex, the first movement is going to be up 1 over 1. Okay, and there's our point. And then we can reflect that. That's where we get that point. The next movement is from the vertex is up 4 and then over 2. So again, this is 1 over 1. This is 4 over 2. The next one would be 9 over 3. So we go from the vertex, we go up 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then over 3. So we get this point here. Oops. And then this point back here. And we get an idea of our parabola. And again, if we had more room on our graph, if we wanted to plot more points, we could. Our next one would be 1, 4, 9, 16, which is 16 over 4 as far as the slope is concerned, and so on. Okay, so that is the first one. I want you to go ahead and pause the video and try and do the second one on your own. And when you think you have it, go ahead and push play and compare what you did to what I did. Okay, for B, our equation says y equals x minus 3 squared. And so when we create our table, xy table, it might be a good idea to plug in those same numbers again. So -2, -1, 0, 1, 2, and so on. And then now when I go to do the work for this one, we're going to say y equals -2 minus 3 squared. So you notice that we have this -3 inside the parentheses here. The order of operations says we have to do what's inside the parentheses first and then square. So we end up with y equals -5 squared. That negative is in the parentheses, so it's -5 times -5, which is 25. That's pretty far up there. I don't know if I'm going to be able to graph that on my graph that I gave you. So let's go on to the next one at -1. So it would be -1 minus 3 squared. So that would be -4 squared, or 16. So that's going to be for our x value of -1. We'll use the 0 now, so y equals 0 minus 3 squared. Well, that would be -3 squared, which is 9. So we can maybe plot that one. That's a little easier. So you can see that this graph is actually going downhill right now. Let's plug in 1. So we get 1 minus 3 squared. So that's going to be -2 squared. Running out of room here. Which is 4. So we can fill out our table there for 4. And then we'll do 2. So y equals 2 minus 3 squared, which is -1 squared, which is 1. Now, I notice in my table that the values keep going downhill, 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 downhill. I know for a parabola that it's got to turn around somehow. And so I want to keep plugging in points until I see where it's turned around. So I'm going to go ahead and add 3 to my table to see what I get when I plug that in. So y equals 3 minus 3 squared. So y equals 0 squared, or 0. So you can see I'm still going downhill. I'm still going downhill there. So that we got to keep going. So we're going to plug in 4. Let's see what happens when we plug in 4. Y equals 4 minus 3 squared. So that would imply that 4 minus 3 is 1, and then square that is 1. So we can put that here. And so now we can see the turnaround. We can see that this graph was going down, 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 up. So we have found somewhere in there the vertex of our parabola. Just as a side note, we can see this. We can see our parabola by the second difference. So we went down 9, we went down 7, we went down 5, we went down 3, we went down 1, and then we actually went up 1. Finding the second difference, we went up 2 here from -9 to -7, and then up 2, and then up 2, and then up 2, and then up 2. So we can see our parabola is there somewhere. Now, I'm going to go ahead and plot these points the best way I know how, the best way I can. So let's go ahead and plot these coordinates. Well, -2, 25 is way off the graph. I'm not going to do that one. And -1, 16 is pretty far up there too. So I'm going to just start at 0, 9. So 0, 9, 1, 1, 2, 3, 4, 5, 6, 7, 8, 9. So there's 1 point. 1, 4. So that's right 1, up 4. And then 2, 1. So right 2, up 1. And then 3, 0. And then 4, 1. So there's the points that I have. And now we can see that we have this symmetry here going on. And so we can see that we actually have an axis of symmetry We actually have a vertex that we can see, okay? But notice that this vertex is not in the same place as our previous example. It's not on the y-axis. In this case, it's the x-axis. So we can go ahead and reflect all our points about the axis of symmetry here. This point's 2 units away, so I'm going to go 2 more units on this side. This point is 3 units away, so I'm going to go 3 more units on this side. And again, I can verify my slope pattern because from the vertex I went up 1 over 1, so there's the 1 for the slope pattern. And then the next one I went from the vertex, I went up 1, 2, 3, 4 over 2. So there's the 4. And then the next one I went up 1, 2, 3, 4, 5, 6, 7, 8, 9. Oops, 9 and over 3. So there's my 1, 4, 9 pattern that I consistently see in these parabolas that we've explored so far. And so just connecting those dots, we end up with something like this. Okay, and I'll go ahead and graph that a little bit cleaner on the lesson here. But the thing that I really want you to focus on, the thing I really want you to see, is where are the vertices in both of these cases? Well, in the first one, the vertex is the coordinate 0, 2. Well, where did the 2 come from? The 2 came from the equation that was given. What is the vertex here? Well, the vertex here is a little bit different. It's not 0, something. It's going to be 3, 0, 3, 0. So we can see, where do we see that 3? We see it here, okay? And so we can start seeing these relationships, these things going on with our parabolas, and seeing a shift. So instead of the vertex just being on the origin, right, at 0, 0, we can see our vertexes are moving in different places. So let's go ahead and take a look at a more in-depth example of this, where it combines both of those equations, and we can compare and look at it in one way. So here's our equation. We're going to go ahead and do this one together. This is an example. So this one should be on the right-hand side of your notes because it's our example. We have y equals, parentheses, x minus 3 squared plus 2. When I create my xy table, I want to plug in values that I will be able to find the vertex easy enough. Now, in the previous example, that x minus 3 really threw things off a little bit. So maybe I'm going to start at -1 this time instead of -2. And it doesn't matter where you start, as long as you can see a pattern going on, you're okay. So -1, 0, 1, 2, 3, maybe 4. And I'm going to go ahead and plug those values in. Well, I'm going to do this kind of in my head here. -1 minus 3, parentheses first, -1 minus 3 is -4, squared, -4 squared is 16, and then 16 plus 2 is 18. And you know what? I'm going to show that work just so we have a reference point. Y equals -1 minus 3 squared plus 2. I plug that -1 in. Again, -1 minus 3 is -4 squared, and -4 squared is 16, and then plus 2 is 18, okay? I'm not going to do that for every one of these. If I plug in 0, 0 minus 3 is -3. -3 squared is 9, and then plus 2 is 11. Plugging in 1 minus 3 is -2. Squared is 4, plus 2 is 6. Plugging in 2, 2 minus 3 is -1. -1 squared is 1, plus 2 is 3. Plugging in 3, 3 minus 3 is 0. 0 squared is 0, plus 2 is 2. And then 4, 4 minus 3 is 1. 1 squared is 1, plus 2 is 3. And so we can see that we are starting to go in the other direction at that point. So let's go ahead and graph this and get a good feel for what happened in this graph. This is an important graph for us today, okay? This is a great classic example of translating a parabola. Not just up and down, not just side to side, but a combination of both. So if I plot the first one, -118 is way up here, so I'm not going to do that one. 0, 11, well, 2, 4, 6, 8, 10, 11. I better do that one. 0, 11 right there, okay? 0, 11. 1, 6, 2, 4, 6, okay? And then 2, 3, and then 3, 2. You can see the curvature going on there. And then 4, 3, 4, 3. And we can see now that we've reflected back up there, we can see our axis of symmetry. Our axis of symmetry in this case is going to be x equals 3. So I'll go ahead and write that down. Axis of symmetry is x equals 3. And then we can find our other points on the other side. Since this is 2 units away, the next point will be 2 more units. And since this one's 3 units away, the next one will be 3 units. Okay. And I could have kept going with the negative 118, but I just ran out of room on my paper. I think this gives us a pretty good understanding of what the parabola looks like here. So there is the graph of the parabola. What is it that I really want you to see here? Well, the vertex, let's go ahead and identify the vertex. The vertex is 3, 2. The vertex is 3, 2. Well, where do we see the 3 and the 2? We see the 3 in our original equation. We see it here. And then where do we see the 2? We see the 2, the y value, at the end there. And so we can see that our vertex shifts according to these two values that we have in our function or in our equation here. I'm going to kind of fly through this a little bit because we just did it. Let's make sure we got it right. So I actually picked an extra point, 5, and I got 6 out for the y value. And then we got this graph that looks something like that. Again, trying to identify key things about the equation so we can see them in the graph. The vertex is 3, 2, and we can see that the vertex is given in this equation here to be 3 and 2 there, okay? So that's it. That's the idea. Now, looking at the parent parabola, remember, is y equals x squared. It has a vertex of 0, 0. We can see all we did with this parabola is we moved it to the right 3 units and up 2 units. We moved it right 3 and up 2. Every point here on the red graph is moved over right 3 units to the right and 2 units up to get to the purple graph. Now, I know for some of us, we might be saying, oh, the purple graph's actually smaller. No, it's not. It's not a smaller graph. It's just that it's a smaller piece of the graph that I have graphed. Remember, this graph is going to keep going up this way and up that way. And so we can see a shift, right 3, up 2. And then this point on the red one is right 3, up 2, and we get the corresponding point. The really important point, though, is the vertex. The vertex was shifted 3 units to the right and 2 units up, okay? And so we can, again, notice that the vertex is shifted 3 units right and 2 units up. So what we're going to do in these problems, it's going to give you an equation like this. It's going to ask you to verbally express what happened to the parent function in order for us to get to this function. Okay, so we're going to maybe write a sentence down, or we're going to verbally say that the parent function, y equals x squared, was translated 3 units to the right and 2 units up. Okay, we'll talk about these signs in just a minute. Okay, so again, let's go ahead and continue on our notes, the right-hand side. This is called vertex form. Actually, this is not the complete vertex form, because you remember yesterday from the lesson, we had an a value, and I don't see an a value in this yet. We're going to talk about the a value on another day more specifically. In this case, though, we have a number here and a number here, or you can see letters h and k, but these represent numbers. Now, these numbers, these h and this k, are actually our vertex. Okay, this is called vertex form. It's the equation for a parabola. Why is it the equation for a parabola and not something else? Because the highest exponent is a 2. Okay, now what I see out of this is that the h and the k represent my vertex. See how this is a minus sign here, and this is a plus sign. What this minus sign indicates is that whatever number you have here as a whole, you're going to change the sign on in order to get this x value for the vertex. The plus sign here means that you don't change the sign for the k value for the y value of the vertex. Let's go ahead and take a look at an example of this, because I know this can be a little bit overwhelming for you. It says identify the vertex, describe the translation, and graph the following function. So this function says y equals x plus 4 squared minus 5. So that's my quadratic function. I want to first identify the vertex. Okay, identify the vertex. Now this is something that you want to get used to. Okay, this is going to be a standard thing moving through all of parabolas, and parabolas are going to take a long time to get through, so pay attention to this. This number, the 4, represents h, okay? And the 5 represents k. We just need to make sure that we get our signs right, okay? Notice, again, this says minus h. So what we need to do is change the sign here so that we would say the vertex is going to be negative 4. So whatever is here, that's a positive 4. The vertex, the x value is negative 4. Okay? And then the k value, because that's a plus sign, we just keep this sign here. We keep it, we carry it with us, so it's negative 5. Our vertex, in this case, is going to be negative 4, comma, negative 5. Now, some of you might be saying, why are you changing the sign on the h and not the k? It's a pretty in-depth explanation, but the best way I think that we can see this is to go back to the problems where we were creating tables and recognizing it through creating tables and understanding it that way. Notice in this graph, the h value is a positive 3, right? The vertex has a positive 3, but when we refer back to the equation, that says negative 3, so we just change the sign. In this case, the y value is 2. Notice in the equation, it's a positive 2, so it's a positive 2 here. That says negative 3, we change the sign positive 3. That says positive 2, we keep the sign positive 2. This guy changes, this guy doesn't. Same thing here. This guy changes, this guy doesn't. So that's a negative 4, that stays the same, that's a negative 5. That's our vertex. The next thing it says is to describe the translation. Well, we can describe the translation without graphing it, because remember, in the parent graph, the vertex is 0, 0. So how do I go from 0, 0 to negative 4, negative 5? Well, I have to say that the parent function, and I'm going to put this, I'm going to define it, y equals x squared, is translated just means shifted, translated, if I could spell, translated 4 units to the left, right? Because we went from 0 to negative 4, so we went to the left, and 5 units down. Okay, so this is our description of what took place. The parent function, y equals x squared, is translated 4 units to the left and 5 units down. And then it says to graph that parabola. Well, we don't need to create a table then. We can just do it based on our parabola here, okay, or based on the equation and based on identifying the vertex. Since the vertex is negative 4, negative 5, we're going to go back 4. 1, 2, 3, 4, and down 5. 1, 2, 3, 4, 5. And that is our vertex. From here, we're going to follow our slope pattern. Remember, our slope pattern is 1, 4, 9, or in other words, it's 1 over 1, 4 over 2, and 9 over 3. I'm not saying that 4 divided by 2 is 4. I'm just reminding you through this slope pattern that the numerator, the top number, has to be those values, okay? So we're going to go up 1 and over 1. We're going to go up from the vertex 4 and over 2, and then up 9, 2, 4, 6, 8, 9, and over 3. And then we're going to reflect that because this is the vertex. We have an axis of symmetry here because the axis of symmetry always sits on the vertex. And then we can reflect that over like this. And then we can plot, oops, I totally messed that up. That point doesn't belong there. and then we can connect those dots in a continuous manner. Notice on my lesson here, notice what I did. I wanted to change this to a minus sign because that's what the vertex form says. It says x minus. So I put an x minus here. Well, what value does this 4 need to be? This 4 needs to be a negative 4 in order for it to be equivalent to x plus 4, because x minus negative 4 is x plus 4. And I wanted this to match the minus sign here, so I had to change the sign there. That's why I'm changing the signs. In this case, this says a plus. Well, what do I have to add to make it say minus 5? I have to add a negative 5. And so you can see your vertex is negative 4, comma, negative 5. And again, the description, we would say that the parent function, y equals x squared, is translated 4 units left and 5 units down. And then the graph, this is going to be a nice, a much cleaner graph than mine. But notice part of it's going to be missing here because I didn't adjust where that graph is going to be. And that's okay. This is the most that I can graph based on the graph that was given. So that is the main idea of today's lesson. If you can identify the vertex by changing the sign of whatever's here and keeping the sign of whatever's there, you can then plot the parabola, plot the points and graph the parabola, and you can describe the transformation. So here is a few practice problems that I would like you to try on your own. And then when you're done, go ahead and push play and compare your results to my results. All right, so I believe there's 4 problems here. All right, let's go ahead and take a look at number 1. Again, you should have already done this before you watch me do it, unless you're completely lost. And I understand that, but then I would want you to pause after we go over this one before we go over number 2 so you can try it on your own. So the vertex in this case, remember we're going to change the sign here. So instead of negative 1, that says negative 1, we're going to change it to a positive 1. And then we're going to keep the sign on this one. Since that's a positive 3, this will be a 3. So there's our vertex. We would say shifted 1 unit right and 3 units up. We're shifting right because that's a positive 1, and we're shifting up because that's a positive 3. And then from here, we can graph it pretty nicely. Let's see here. We'll go with that. Vertex is 1, 3, so right 1, up 3. And then we'll follow our slope pattern. So the first one, remember, is up 1 over 1. The next one from the vertex is up 4 over 2. And I'm kind of running out of room on my graph. So duplicate that on this side, and we have our parabola. So hopefully you got that correct. Now, I have a bunch of other examples here because I want to make sure that we see all different examples of the signs, what happens with these signs, and be consistent with that. I also have a negative there. Let's see what happens with that guy. For number 2, we've got y equals x plus 2 squared minus 4. So our vertex, remember, change the sign here. So that'll say negative 2. And then keep the sign there. So that'll say negative 4. We would say the parent function, y equals x squared, is shifted 2 units left and 4 units down. To the left because that's a negative 2, so that means backwards, and then 4 units down because we're going down. So let's go ahead and graph this guy and see how we do. Notice I'm setting up my XY graph because I kind of know where it's at. Negative 2, negative 4 means back 2 and down 4. So I want to make room for that. That's back 2, down 4. Then we follow our slope pattern. So we go up 1 over 1, up 4 over 2, and then up 9. I might run out of room here. 1, 2, 3, 4, 5, 6, 7, 8, 9, and over 3. Again, when I'm counting from the vertex each time. Then we have our axis of symmetry based on our vertex, and so we can reflect all those points onto the other side. All right, and there we have our parabola. And again, some students would say, well, this parabola is bigger than the other one. It's not bigger than the other one. It's exactly the same size. The only difference is There's more of this parabola showing than this guy because the graph cut out up here. So there's just more room to put this parabola. It's not that it's bigger or smaller, okay? All right, let's take a look at, and I'm kind of running out of paper here. So let's look at another problem, number 3. Number 3 is a little bit more unique because of that negative sign, or sorry, yeah, that negative sign there. Y equals negative, parentheses, x plus 6 squared. Well, what's our vertex? Our vertex is the same rule as we did before. This value is our x value, but remember we changed the sign, so that'll say negative 6. And then we look at our k value, go, oh, there's no k value there. There's nothing there. So what's the k value? It's 0. Our vertex is negative 6, comma, 0. And then we could say that this was shifted 6 units left, and that's it. We don't even have to put an and because we didn't move the 0, right? The vertex normally is 0, 0, so we didn't have to move that. So it's just shifted 6 units left. Now, one thing else I'm going to add to this is that, see the negative out front? What does that mean? Remember, that means that the parabola, instead of opening up, is going to open downward. The way we express that is we say that it's reflected about the x-axis. Now, we'll talk more about that in the future, and that should actually go first. But again, we'll talk about that more in the future. The main focus for today is the shift. So let's go ahead and graph this guy. The vertex is negative 6, comma 0. So negative 6, that's way back here, 2, 4, 6. Ooh, boy, I'm running out of room. I should have moved that axis in a different place. But negative 6, comma 0, there's that. Now, again, we know that this parabola opens downward because of the negative. So instead of going up 1 over 1, we're going to go down 1 over 1 and put a point. And then from that vertex, from the vertex again, we're going to go down 1, 2, 3, 4, and over 2. And again, down 1, 2, 3, 4, 5, 6, 7, 8, 9, over 3. So there's at least half of the parabola. And then the other half, I'm running out of room on my graph paper. I'm going to reflect over here. So that's that part. And then this one might be here, and this one might be over here. Shame on me for running my graph outside the graph paper. Tisk. But if my graph ends here, then I would just stop graphing right there. And I could put an arrow there and an arrow there. But I'll go ahead and just keep going so we can see it. All right, so there's our parabola for number 3. Again, it opens down because the a value is negative. Oops, a value is negative. And then we have a vertex of negative 6 because we changed the sign, and then 0 because there's no k value there. All right, number 4, last problem. Y equals x minus 3 minus 1. I got you on this one. I got you. What's different about this graph? What's different about the function is that there's a square missing. Now, you might think, Mr. Bunye, you made a mistake. You forgot to put the 2. But you're wrong. Because I want you to see something about this function versus that function. I want you to see something. Now, this is not a parabola. This is actually a line because the highest exponent is 1. And I'm going to show you it off to the side. If I simplify this, we can just drop those parentheses. There's nothing to do with those parentheses. You can't combine them. We could put a 1 out front and distribute, but that's going to be x minus 3 minus 1, and that simplifies to x minus 4. Well, look at that. Look at that. That's a line. That's a linear equation. That's a linear function. But let's look at it in the light of how we were dealing with parabolas so you guys can see the comparison. We would say that the vertex is positive 3, comma, negative 1. That's what we would say. Now, granted, it's not a vertex, but it's a point. It's some point on the line. It's 3, comma, negative 1, okay? 3, comma, negative 1. So that means we're going to go to the right 3 and down 1. So there's our starting point. That would be the vertex of a parabola. In this case, it's just the starting point that we're going to start at. Now notice, what is the number in front of the parenthesis here? The number here is 1, okay? That is our slope. That's the slope of the line. Now, notice here, this is a negative 1. Well, that negative implies that the parabola opens downward. And the 1 implies that it holds to the normal slope pattern of 1, 4, 9. In this case, it's not a parabola, so it's not a slope pattern, it is the slope. So if we have a slope of 1, that means we're going to go up 1 and to the right 1, up 1 to the right 1, up 1 to the right 1, and keep going. But we can also go down 1 and back 1, down 1 and back 1, down 1 and back 1, down 1 and back 1. And so you can see our linear equation, our linear graph here, okay, based on the vertex, not really a vertex, but based on that point according to this equation. But one thing I want you to see is if I were to ask you to graph this line, which you guys agree was the same as this one because I just distributed and combined like terms, where would I start on this graph? I would start down 4 for my y-intercept, and I would follow a slope of up 1 over 1, up 1 over 1. So even though I started at a different point, the slope was the same, and it ended up having the same y-intercept, okay? So you can see that this comparison between linear functions and parabolas, this point is an identified point, whether it's the vertex of a parabola or the point on a line. And then we follow either the slope of the line or the slope pattern of the parabola, okay? So with that said, I'm just going to put two that are right next to each other so you guys can see the difference between them. Y equals negative x minus 2 plus 1 versus, we're going to do the same exact thing here, but we're going to put the squared. So negative x minus 2 squared plus 1. So there's our two equations, okay? One of them is a line, one's a parabola. This one's the line because the exponent's a 1. This one's a parabola because the exponent's a 2. We would, in this case, start off at 2, 1 because we change the sign and we keep the sign. Here, we're going to start off at 2, 1 because we change the sign and keep the sign. Okay? And then from there, we follow the slope. So we're going to go right 2 up 1, and then we're going to follow the slope. The slope says negative or negative 1, which means we're going to go down 1, right 1, down 1, right 1, down 1, right 1, and then opposite ways that way. So we can see our line here. Notice the point that we started with was 2, 1. Okay? For this guy, we're going to start at 2, 1, okay, because that's the vertex. And then we're going to follow the slope pattern of down 1, right 1, because it's a opening down, and then down 4, right 2, and then down 9, 1, 2, 3, 4, 5, 6, 7, 8, 9, right 3. And then we'll repeat that, reflect that over on the other side. And so we can see our parabola, taking shape. Okay. Well, what do they have in common? What do they have in common here? They have the same point. 2, 1, 2, 1. We started at that point. Then on this one, we followed the slope, the constant slope. And on this one, we followed the slope pattern. And the slope is changing as time goes on because it's getting steeper and so on. So that's the difference between linear and quadratic in that regard. Hopefully you guys have a good understanding or a better understanding of how to take a normal parabola and shift it around and reflect it, following the vertex, right? Following the vertex and following the slope pattern. With that said, go ahead and make sure you get your homework done. Make sure you're writing summaries on this. Make sure your name is in your notes. Get that turned in and then get going on your Delta Math or whatever homework assignment you have. And I will talk to you again next time.